The hardware. From a designer's point of view, this was probably the most difficult part to address. I asked for or bought evaluation boards from different controller manufacturers. Here are some key moments in the hardware design for wiring. Prototype 1. The first prototype for wiring used parallax javelin stamp controller. It was a natural option since it was programmed in a subset of Java language, which was already being used by processing. Problem. As described in the thesis document on page 40, compiling, linking, and uploading of users' programs relied on parallax proprietary tools. Since writing was planned as open source software, the Javelin stamp was simply not a viable option. For the next prototypes, microcontrollers were chosen on a basis of availability of open source tools for compiling, linking and uploading the user's code. This led to discarding the very popular microchip PIC family of microcontrollers very early, because at the time, circa 2003, microchip did not have an open source toolchain. Prototype 2. For the second wiring hardware prototype, the Atmel ARM-based AT91R4008 microcontroller was selected, which led to excellent results. The first sketch examples were developed and command naming testing began. For example, pinwire used to be the name of the now ubiquitous digital wire. Digital write, pin write, digital write. The Atmel R4008 served as a test bed for digital input-output API and the serial communications API during my evaluation of its capabilities. The Atmel R4008 was a very powerful microcontroller, but was far too complex for a hands-on approach because it was almost impossible to solder by hand onto a printed circuit board. For more information on this prototype, see page 42 in the thesis document. Prototype 3. The previous prototype experiments led to the third prototype, where the microcontroller was downscaled to one still powerful, yet with the possibility of tinkering with it without the requirement of specialized equipment or onboard extra peripherals. I selected the Atmel Atmega 128 microcontroller and brought an Atmel STK500 evaluation board with a special socket for the Atmega 128. Tests with the STK500 were immediately successful, so I bought a Maverick board from BD Micro with the Atmega 128 soldered. Brian Dean's work on his Maverick boards were unparalleled at that time, and his work drove him to build a software tool to easily upload new programs to his board. It is still used today in Arduino software and is called AVR Dude. As traditional COM ports were disappearing from computers, I selected FTDI hardware for communication through a USB port on the host computer. FTDI provided drivers for Windows, macOS 10 and Linux, which was required for the wiring environment to work on all platforms. FTDI evaluation board was interfaced with Maverick board and tested with the third wiring prototype. In early 2004, based on the prototype using the Maverick board prototype 3, I used Brian Dean's and Pascal Steng's schematic designs as a reference to create the first wiring board design. It had the following features. At Mega 128, FTDI 232 BM for serial to USB conversion, and onboard LED connected to a pin, power LED and serial RX TX LEDs. I used Eagle PCB from Catsoft to design the schematic and printed circuit board. Wiring board printed circuit board layout. Along with the third prototype, the final version of the API was tested and refined. More examples were added, and I wrote the first LED blink example that I still use today as the first sketch that a user runs on an Arduino board to learn the environment. Even more examples were developed to support liquid crystal displays LCDs, serial port communication, servo monitors, etc., and even to interface wiring with processing via serial communication. Details can be found on page 50 in the thesis document. In March 2004, 25 wiring printed circuit boards were ordered and manufactured at SERP and paid for by IDE. I hand soldered these 25 boards and started to conduct usability tests with some of my classmates at IDE. It was an exciting time.